class. I'm not able to be there this afternoon, so I'm going to give you a few notes on section 6.1, and then you can start practicing the problems on a worksheet. You should have torn out pages 167 to 182 in the journal. I'd like you to turn to page 170, the bottom of page 170. And if you go to the bottom, this is what we did yesterday. Just to review, a to the 0 power is 1 anytime. Negative exponents, if you remember from when we were graphing exponential functions, 4 to the negative second power is the same as 1 over 4 to the second, which would be 1 over 16. Okay, so that will hold true. Flip to page 171. This is what we talked about yesterday too. To multiply powers with the same base, add their exponents. So if you had 4 to the 6 times 4 to the third, you get 4 to the 6 plus 3, which is 4 to the ninth. To divide powers with the same base, you subtract their exponents. So in this case, we did 6 minus 3 was 3. 4 to the third power is simplified. For a power to a power, to find a power of a power, multiply the exponents. So let's say you have 4 to the 6 to the third power. So that means 4 to the 6 times 4 to the 6 times 4 to the 6 is really 4 to the 18th. So to find a power to a power, you multiply the exponents. Okay, and then if you look at this, to find a power of a product, find the power of each factor and multiply. So just looking at this, we have 3, this is to the 5th power, and 2 is to the 5th power. So 3 to the 5th times 2 to the 5th. We can get rid of the parentheses and take them each to the 5th power individually because it's multiplying in between. Power of a quotient property, look at this. So if we have 3 over 2, 3 halves to the 5th power, it's the same as 3 to the 5th power and 2 to the 5th power. Okay, so you could break it up that way, which will help. Okay, you can always refer back to those on page 171. Okay, going to the next page, take a look at extra practice number 1. Okay, the directions on 1 through 8 say evaluate the expression. You want to find the value. Like 3 to the 0, you just put 1. We get to number 3, 3 to the negative 4th power. Remember, this is the same as 1 over 3 to the 4th. So you multiply that out on the bottom. 1 over 3 to the 4th is 81, the same as 9 times 9. Over here, let's move down to number 5. This would be 2 to the negative 3rd over 1. So 2 to the negative 3rd is the same as 1 over 2 to the 3rd power, which is 1 over 8. Okay, so moving on to number 7. Same thing. This on the bottom is just 1. So really you're dealing with 4 to the negative 1st, which is 1 over 4 to the 1st power. Okay, moving down then to number 9. To simplify the expression, write your answer using only positive exponents. So on this one, only positive exponents. So we want to try and get rid of those negative exponents there that we have. So if you skip to number 10, a to the negative 8th. Negative exponents, remember, it's 1 over a to the 8th power then. That is a positive exponent. So look at it, it was, normally you kind of think of it like this. If you put the new fraction bar, it was on top, it was negative, it was unhappy, we put it on the bottom as 1 over. So we look at number 11. A lot of times I just draw my fraction bar. And then 6 is 6 over 1, so that stays on the top because it's happy. It has a positive exponent right now. A to the 0 really is just 1. B to the negative 2nd is really 1 over b to the 2nd power. So I put the b to the 2nd on the bottom, and this is my final answer. Okay, so going on to number 12, just to keep looking at examples, I put my fraction bar. This is 14 over 1. It stays on the top in the numerator. M to the negative 4th. This is a negative. It needs to go downstairs, we sometimes say. It needs to go to the bottom. N to the 0 power is 1, so I can really just ignore that. Okay, number 13. Here's my fraction bar. S to the 0 power, that's just 1, so that we can Just make that into a 1. 3 to the negative second power, remember, is 1 over 3 squared. R to the negative third is really 1 over R to the third. So that goes downstairs. And then that equals, multiply it out, 1 over 3 squared is 9, R to the third power. Okay, keep going. Put a fraction bar. I look, 2 to the third, I can go ahead and just put 8. A to the negative third, that would be what? A to the third on the bottom. 8 to the negative first power. So down here, if it's a negative in the denominator, a negative exponent like this, remember it's really like 1 over 8, which would really be the reciprocal of that. So it becomes an 8 on the top, 8 to the first power on the top in the numerator. B to the negative fifth, I need to put up here. And then C to the 0, that's really just 1. Okay, let's look at what I did again. 2 to the third was 8. 8 to the negative first power, I needed to get it out of the denominator and put it in the numerator. It's a positive 1. 8 to the negative third was unhappy. It's a negative exponent, so it needs to become a positive exponent downstairs. B to the negative fifth was negative, unhappy in the denominator, so it becomes b to the positive fifth in the numerator. Go ahead and clean it up a little by doing 8 times 8 is 64, b to the fifth over a to the third. Circle and finished. Okay, moving on to the next row, 15. That one, it's divide, so it's just 3 to the second, which is 9. Let's move on to down to number 18, power to a power, q to the 15th. That's it. That's all you have to do. So you keep the same rules apply. So when we look at number 19, a to the negative fourth to the second, power to a power, you multiply. If you sometimes put a dot there, so it becomes a to the negative eighth. Well, it said, the directions said I had to use positive exponents, so it's 1 over a to the 8th power. Okay, number 20, let's clean up what I have on the top first, which is c to the 7th, because when I multiply, I add the exponents over c to the 6th. When I have division, I subtract, so I really get c to the 1st, or just c. Okay, on 21. Looking on 21, I get negative d. Hold on. Okay, on number 21, this is the part that was on the bottom of page 171. To simplify this, I take negative 4 to the 4th power, and then I take d to the 4th power. So I take each of the factors to the 4th power. So negative 4 to the 4th power, 16 times 16 is 256, positive, and then d to the 4th. Okay, 22, so I would think of that as my two factors. So I take negative 3, parentheses, to the negative 3rd power, and I take f to the negative 3rd power. So to simplify that, negative 3 times negative 3 times negative 3, but this was to the negative 3rd power. So hold on, the first thing I want to do is make it 1 over negative 3 to the 3rd power. And then f to the negative 3rd goes on the bottom also as f to the positive 3rd. Clean it up, 1 over 27 negative 27 f to the positive 3rd. Let's talk about that one again. Negative 3 to the negative 3rd power, f to the negative 3rd power. So I take each of the factors to the negative 3rd power. Draw my fraction bar. I don't want to have a negative exponent, so I make that as 1 over negative 3 to the positive 3rd, and then f to the 3rd on the denominator to get rid of the negative exponent. Then I take negative 3 times negative 3 times negative 3, which is negative 27, f to the 3rd. That negative sign, it can be here, it can be on the top, or it can be out in front. It's just hard to write neatly with this pen. Okay, 23. 4 to the negative third, same thing. I can take that negative 3 exponent and it goes to both the 4 to the negative third and the x's to the negative third. Okay, I can't have negative exponents, so I want to switch these two. 4 is unhappy, so it's negative, so I want to put it downstairs as 4 to the third. X to the negative third needs to go upstairs as x to the third. Clean it up, x to the third over 64. And then I'm finished with that. Okay, on the bottom, a rectangular prism has a length x, width x over 2, height x over 3. Which of the expressions represent the volume of a prism? Select all that apply. So remember, with volume, it's equal to length times width times height. So you can multiply those. X times x over 2 times x over 3. So really, I'd get x to the third over 6. So this, if I look at this, this is the same as if I evaluated this, it would be x to the third over 6. If I put my fraction bar over here, I'd get 6 on the bottom and x to the third on the bottom. So that's not true. I liked A. This one would be 6 to the negative first times x to the negative 3 times negative 1 is positive 3. Clean it up, and I would get x to the third would stay in the numerator. This one would go down here, which is what I started with. So C was a good one also. Okay, on this, I could do 2 to the negative first, which is 1/2, times 3 to the negative first is 1 over 3, times x to the third. 1/2 times 1/3 is 1/6, times x to the third. That looks like the same thing I have right here, 1/6 times x to the third, so D is a good option also. Okay, that's the end of the notes. You can go ahead, the substitute will pass out the worksheet 6.1, the practice, and then I also want you to do the journal, page 167, 1 through 14, which should be review over order of operations and finding square roots. Okay, have a good day.